Hi everyone, let's go ahead and get started with the green worksheets. We are going to be working on the first one today, front and back, and whatever examples are left unfinished, those are yours that are going to be homework. Okay, you will have time in class to work on these as well, so that's what you should be using first off. A solution to a system of inequalities satisfies both inequalities. So when we are given a system of inequalities and we're given an ordered pair, we are going to be looking to see if that ordered pair makes both equations true. So the equations that they gave us are y is less than or equal to negative 4x plus 1 and 2x plus 3y is greater than 11. So what I'm going to be doing first is I'm going to rewrite the equations out without the variables and replace that with a set of parentheses. So we're going to have y is less than or equal to negative 4 times x plus 1. Our second equation is 2 times x plus 3 times y is greater than 11. Okay. All right, so the values that they gave us here for x is negative 3 and for y is 7. So here we had y, which is 7, is less than or equal to negative 4 times negative 3. So simplifying the left side is just 7. Simplifying the right side, I get positive 12 plus 1. And that gives me 7 is less than or equal to 13. That is a true statement. Okay, so it does satisfy the that inequality, but I need to make sure that it also satisfies the second inequality. So here we have 2 times x, which is negative 3, plus 3 times y, which is 7. So I've got negative 6 plus 21 is greater than 11. So is it true that 15 is greater than 11? Yes, that is true. Since both statements are true, then this is a solution. All right, so on this next one, and as you've noticed, I've just wrote in the equation every time just to save up time from shortening the video. Okay, so you can go ahead and pause this and fill this in when you're ready to do this section, or go back and just copy that piece. All right, on this one, they want us to check if the solution, or if the ordered pair 1, 5 is a solution. 1 is the x value, 5 is the y value. So I've got 5 less than or equal to negative 4 times 1 plus 1. So is 5 less than or equal to negative 3? And let's see, 5, negative 4 plus 1. 5 is not less than negative 3. It is actually greater than negative 3. Okay, so once I find that it is not a true solution for the first equation, as long as I feel comfortable with my math, which I do in this case, we're going to go ahead and say, no, that's not a solution. Could we go ahead and check this one as well? Well, of course we could. We could plug in 1 and plug in 5, and we would get 2 plus 15 is greater than 11. So is 17 greater than 11? Yes, that's true. However, since they're both not true, or since one of them is false, that makes it not a solution. Okay? All right, so then these two here are going to be yours for your homework tonight, or for this afternoon. Practicing, even if you pause the video now and continue practicing with those two, you can, and then just come back to go on to the next ones here. Okay, so the next thing we're going to be talking about is how do we find a solution when we are given a system of inequalities? Well, we cannot use substitution and we cannot use elimination. The only way to solve a system of inequalities is by graphing it. So if we need to find what the solutions are, not given the ordered pairs, we will need to graph it. Okay. Now in the intro, I talked about solid lines, solid boundary lines and dashed boundary lines and shading above and below. So if you have not watched this yet, go back and watch that first intro video. So here we've got y is greater than or equal to 1/3 x minus 2. This is going to be a solid boundary line. And when we shade, we are going to be shading above because it is greater than. Okay. And then we have y is less than negative x plus 2. So since it's less than and not equal to, this one is going to be a dashed boundary line. And we are going to be shading below. Okay. So I'm going to be using two colors of highlighters here. So if you have a pencil and a pen, that would be helpful. Or if you have highlighters, you can use those as well. Okay, so the first one, I'm going to graph this one in red. So the solid line, they've already graphed this one for us. So that solid line is where I'm going to be shading above. So everything above that line. Okay. Entire part of the graph above it, not below it. Please don't make that mistake that I just did here. We don't want to be below that. Okay. And then the next part, I'm going to be shading in blue. So looking at the dash line, I'm going to shade everything below the dash line. And I'm going to go back to that little segment over there because some people say, hey, well, that's not under the dash line, when actually it is. So I'm going to go back to it, I promise. But I just want to show you what I'm seeing here. So this here is definitely what appears to be under the dash line, okay? But this stuff here is also underneath the dash line because we're only getting a small glimpse of this overall graph. But this dash line really continues on and on and on forever to negative infinity. So all of this here is still underneath that graph. Okay? All right, so now which of the following ordered pairs are solutions to this system above? So I'm going to go ahead and pick a couple of these random ordered pairs to check if they are or are not solutions. Okay, so let's see. I want to go with, I think I want to go with negative 2, 4. So I want to try this one right here. So if I go over to negative 2 and up 4, I am looking for any point that is in the area that overlaps with the red and the blue. Negative 2, 4 touches that area with red and blue. However, it is on a solid line. I'm sorry, on a dashed line. Remember, dashed lines are never solutions. Again, that is something that I talked about in the intro video. Dashed lines are never solutions. So negative 2, 4 would not be a solution. Okay. All right, what about 0, 1? So when x is 0, y is 1. Is that in the area that is overlap with the red and the blue? Yes. Is it on a dashed line? No. So that means that this one is a solution. Okay. Well, let's try 6, 0. So when x is 6, 1, 2, 3, 4, 5, 6, and y is 0, is that one a solution? Well, it lands on a solid line. However, that solid line is only touching the red. It needs to be touching the red and the blue. So this one here is not a solution. Okay. All right, one more. I'm going to do 3, -1. So I go over 1, 2, 3, go down -1. In this case, I want to know if that point right there is ever a solution. Okay, so it does touch the area that is both red and blue. Okay, and it is on a solid line, so it appears that it could be. But this rule here still applies. It cannot land on a dashed line. That one is also on a dashed line, so this one is not a solution. Okay. So if it had landed here, that would be a solution. Here, that would be a solution. Okay. Even here, that would be a solution. Let me put a couple on here in red, though, that would not be a solution. Okay. This one would not be a solution because it is not where the red and blue overlap. This one is not a solution because there is no red and blue overlapping there. This one here, not a solution because there's no red and blue overlapping there. Okay? All right, so these remaining ones are for you to determine whether they are or are not solutions. All right. Now, let's go on to graphing some systems of inequalities. So when we are graphing them, first off, make sure they are in slope-intercept form, y equals mx plus b. Okay. Once they are in slope-intercept form, then we can graph them. However, we'll need to know if it's a solid line or if a dashed line, and whether we're going to shade above or below. So looking at this first example that I have starred here, y is less than, so that means it is going to be a dashed line. Okay, and since it's less than, that means we're going to shade below that dashed line. All right, on our second graph, y is greater than or equal to, so that one's going to be a solid line. And if it's greater than, then that one is going to be shaded above. All right, so let's graph that first one. It starts at +2. That's our y-intercept. And down 2, right 3. For that slope, down 2, right 3. That's a dashed line. And we are shading below that dashed line. Okay. Then we've got a solid line for this next one. The y-intercept is 0, and the slope is up 1 over 1 because the value in front of x is 1. Okay. So that one there is a solid line. And that one we are shading above that. Okay. And our solutions would fall, let's see, I'm going to go ahead and label these A, B, C, D. There's 4 different areas that we have there that it's divided up into. And our solutions would fall into the section D as long as it's within that section or on a solid line. Cannot be on the dashed line. Okay. All right, so let's jump over to the next one that we're going to graph. It's the third one over. Then on this first one, y is greater than, so this one is going to be a dashed line. And it is going to be shading above. Okay, The second one is going to be y is greater than. So that's also going to be a dashed line. And it's also going to be shaded above. All right, so y is greater than 3x minus 3. So starting at negative 3, and we're going to go up 3 over 1, up 3 over 1. Okay. Draw a dashed line through those points. And we are going to shade above that one. All right, on this next one, we've got y is greater than negative 2x plus 1. So we start at positive 1, go down 2, right 1, down 2, right 1. Okay. Go ahead and draw that dashed line all the way through the coordinate plane. And then we are shading above on that one. Okay. All right, so we are looking for the section. I have A, B, C, and D. And the section where our solutions will be is in section A. However, in this case, it won't land on any of the lines because they are all dashed lines. Right? So it can land between that area, but not on any of the lines. Okay, one more to complete of this type. So here I have x is greater than or equal to negative 2. That is going to be a solid line, and it is one of our special cases, and we talked about this in the introduction. When it's x is greater than or equal to, and or negative 2, and there's no y value, this special case is going to create a vertical graph. Okay. Right? So I'm going to draw this in a different color so that we can see it, because I'm going to go to where x is negative 2, and I'm going to draw a vertical graph right through that. Okay. Now, to know where I'm going to shade, x is greater than negative 2, which values would be greater than negative 2 on the x-axis? Would it be negative 1 or would it be negative 3? Well, our answer for that one would be negative 1, because negative 1 is greater than negative 2. 0 is greater than negative 2. Then positive 1, positive 2. These are all greater than negative 2. So when we're looking for stuff that is greater than this special case, or greater than negative 2, it's going to be shading to the right of that line. Okay? Now what we're going to do is we're going to go ahead and graph that second one. The second one is also a solid line, and its y is less than, so we're going to be shading below. Okay. So we start at negative 4, and then we go down 5, right 2, or we can go up 5, left 2. Okay. That one there, draw a solid line. Okay, that was not a solid line for sure. Okay. And on that one, we are going to shade below. Okay. All right, I'm going to go ahead and identify those 4 different sections so we can see where you think our solution would be. We've got A, B, C, and D. Okay. This one here, our solutions are in section C and could land on either of those solid lines because they are both, those would both make it a true statement. Okay. All right, last thing that we are going to do together is hold on, two more things. First one is we are going to look at what happens when we have parallel lines. Remember that parallel lines never intersect. Okay. However, there can still be solutions when it comes to inequalities, because in this case, we're talking about shading. All right. So this first one, y is greater than 1/2 x. So this is going to be a dashed line, and it's going to be shaded above. Okay. Then the other one that we have is y is greater than or equal to. So that one's going to be a solid line, and it is also going to be shading above. So for the first one, when it's a dashed line, it's 1/2 x plus 1. Remember, parallel lines have the exact same slope but have different y-intercepts. Okay, not in order to be parallel, that are not touching, I should say, or not stacked. So this one here is, we are shading above this dashed line. Okay, now for the second one, when we're looking at the solid line, we are also shading above that one. Now, when we're shading above it, we are not just shading up to the dashed line. We are shading everything that is still above it, okay? So everything above that solid line. We're trying to see if there's anywhere that the red and the blue overlap. In this case, we have section A, section B, and section C. If our solutions fall within section A, it'll be a solution. Again, it cannot land on the dashed line, right? All right, so looking at this last one over here, y is greater than, so that's going to be a dashed line, and it's going to be shaded above. So if y is greater than the dashed line, it's going to be everything above that dashed line. Okay. Now let's see if any blue overlaps that. On this next one, we have y is less than or equal to the solid line or graph of 1/2 x minus 2. Again, notice that our slopes are exactly the same. All right, in this one, we've got section A, section B, and section C. In this case, none of them have any area where the colors overlap. So this one would be no solution. Okay. All right, last two pieces here. So I want to write equations for two of these graphs. All right, the first one, I'm going to go ahead and label this one equation A, this one equation B. Okay. All right, on equation A, I can see that it's decreasing, so it is going to be less than, and it is a solid line, so it's also going to be equal to. Okay. So I know that I'm going to have y is less than or equal to. Wait a minute. Nope. Got to go back. Because it's not less than or equal to. Even though it's a solid line, I need to look at whether it's shading above that line or below that line. And since the shading is happening above it, it's going to actually be greater than or equal to. Okay. So y is going to be greater than or equal to. All right, now we need to find the slope of that line. So from this point to this point, it goes down 1, right 3. So -1 over 3x. And then our y-intercept is at +2. Okay. All right, now let's go look at the second equation. This one here is going to be not equal to. Is the shading above or below this line? Well, it's above, so it's going to be, the y value is going to be greater than, again, not equal to. Okay, we got to find our slope of that line. So I'm going to pick 2 points. I'm going to pick this point to this point. Okay, so that's up 1 over 1. And the y-intercept is at -2. Okay. All right. And for this next one, I'm going to call this A, and I'm going to call this B. Okay. So for A, if I'm looking at A, I can see that there's shading above it. So it's a dash line. So it is going to be greater than, but not equal to. So y is greater than. Now this is a horizontal line. So this is a special case. Okay, so with those special cases, remember, if it's a horizontal line, this time it will have no x value because it never crosses the x-axis. So this is y is going to be greater than wherever it crosses that y-axis at +2. Okay, there's no slope on that one. It's just the y-intercept at 2. Now, for the B, B is a solid line. This case, we are shading below. So y is going to be less than or equal to. Okay, the slope of that line, I've got to pick 2 points. I'm going to go ahead and pick this one and this one. So the slope goes down 4 over 1. The y-intercept is at -1. Okay? All right, so anything else on this first page that we did not complete is yours to work on for practice. Whatever you cannot finish in class is for homework.